Sets F is a set of factors of 12. List the elements of the set F. Factors of 12 are 1 multiplied by 12, 2 multiplied by 6, and 3 multiplied by 4. So it's going to be the numbers 1, 2, 3, 4, 6, and 12. Alright, next part. Sets P and S are as follows. P is the set of all prime numbers. S is the set of all squared numbers. The Venn diagram shows F, P, and S below. Now, what we're going to do, write each of the factors of 12 in part A into the correct region of the set F in the diagram. Okay, so we're going to write down our answers from part 1, and we're going to put them into the diagram to see where they should go. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, so first of all, we're going to look at prime numbers. The only two prime numbers are 2 and 3. Okay, and square numbers are 4. Okay, so a square number is 4. A square number is 4 because it's part of F and it's a square number, so it's 4 in here. 2 and 3 aren't square numbers, so they're going to go here. 2 and 3. They're part of F and they're prime, so that's 2 and 3. Okay, and then all the other numbers belonging to this are going to be 1, 6, and 12 belong to F, but they aren't prime and they aren't square numbers. Okay, so that's what our graph should look like. Okay, next part of this question. Oh, that's it. It turns out. Yeah, that's it done. Next one, work out the value. So it's 3 times whatever P is minus 4 times whatever T is squared. So 3 times P is 18. 5 squared is 25. Minus 4 multiplied by 25 is minus 100. 18 minus 100 is minus 82. Next part. Multiply out and simplify. So 2x multiplies by everything in this bracket. So it's going to be 2x times 4 is 8x. 2x times 5x is minus 10x squared. 2x times x squared is 2x cubed. Minus 3 times 4 is minus 12. Minus 3 times 5x is plus 15x. And minus 3 times x squared is minus 3x squared. Next thing, 2x cubed. Minus 10x squared minus 3x squared is minus 13x squared. 8x plus 15x is 23x. And then finally the minus 12 is left over to your side, and you're done. Okay, because minus 10 minus 3 in the calculator is minus 13. Okay. Now let's move on to part C. Is there part C? Oh, there it is. Now, when you're factorizing these, see the way if you take out, you can't take anything out with these two here because they have nothing in common. So here'd be my suggestion. Do 10DE minus 5EF. See the way the 10 leads to 5. Then put the 2 in front of the 1DF. 10 is twice 5, 2 is twice 1. You can do it that way. Okay. What do they have in common? They have 5E in common, 5E bracket. 5E multiplied by what gives you 10DE? Well, that'd be 2D. And then 5E multiplied by minus F gives you minus 5EF. Then take out D. And then you're left with 2D minus F as well. And then double bracket 5E plus D. Oh, sorry, 5E, my fault, plus D. Yeah, I was right. Sorry, 5E plus D bracket 2D minus F. Check your answer. 5E by 2D, 10DE. 5E by minus F, minus 5EF. D by 2D, 2D squared. And finally, D by minus F is minus DF. So I knew I got everything right there, so there's no need to worry about the answer anymore. Okay, good. So what I've done here so far is I've done 4 and 5 so far. Okay, let's move on. Question 7. This guy has an unlimited supply of €5 notes and €2 coins. Fill in show 3 different ways which you can make €27. Well, you can do 5 €5 notes and 1 €2 note. So you can do 5 by 5 is 25, and then 1 €2 note. So 5x5 is 25, and then 1x2 is 2. 1 €2 coin, 5 €5 notes, add them together, €27. Way number 3, well, we're going to need an odd number, so let's try an odd plus an even. So what about 15 plus 12? 3 €5 notes and 6 €2 coins gives me €27. Okay. Explain how we could use a supply of €5 notes and €2 coins to make every whole number greater than 3. Okay, you can do 2 plus 2, which is 4. Then you can do he has 1 €5 note, which is 5. Okay. So I think the way we do this is via multiplication. Okay, so what we can say is 2 by €2 equals €4. 1 by 1 €5 note is 5. So what we can say here is we can make any even number. We can make any even number above €2 using €2 coins. Okay, next thing we can say is we can make any odd number or above 4 using 1 €5 note and any amount of €2 coins. Any required amount of €2 coins. So you could have a 5, and then you have a €5 plus a €2 to get a 7. Then you can have 9, 11, 13, all the way out. And then you also have 2, 4, 6, 8, 10, and then combined it's all numbers above 4, all numbers above €3. Okay, that's good. So that was question 7. Next thing I'm doing is question 8. Solve this. So use the minus b formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. So a equals 1. B equals minus 4. Minus b equals plus 4. And c equals minus 7. Put it into the calculator, and we get we're going to get plus 4 plus or minus the square root of b squared. B squared is going to be minus 4 squared minus 4 times a times c all over 2a. So we're going to throw this into the calculator. So it's going to be 4, press the fraction button early on, guys, plus square root minus 4 squared minus 4 times 1 times minus 7 all over 2 times 1. And we get 2 plus root 11, which is 5.32. How many decimal places? 2 decimal places. So 5.32. And then go back and change it to a minus. And we get minus 1.32. Okay, happy days. Okay, that's question 8. First part of 8 done. This is functions now. So look, we can just quickly do this. The solution, when you see a x squared, it's a U-shaped function, and when it says the solutions x equals -1, x equals 2, that's where it crosses the x-axis. So you can see that they all cross. Oh, sorry, they don't. This one doesn't cross. This one crosses at x equals -2 and x equals 1. That eliminates that one out. So it can be either of these two equations here, where they cross at 1, -1, and 2. Okay, so what I would do here is, you're looking to figure out what is this graph. What I'd do is, this is the y value. I'd find out the y value when the x value equals 0. So when the x value equals 0, it's going to be y equals 0 squared minus 0 minus 2. Then the y value has to equal -2. So this means it crosses the y-axis at 0 minus 2, which is this one here. And that's your answer. And this justifies your answer. Crosses y-axis at 0, 2. At 0 minus 2. Okay, so that's 8. Question 9. A group of friends makes a video and posts it on YouTube. They know that they'll be paid approximately €15 for every 10,000 views of the video. Work out how many views of the video they need in order to be paid €45. So if €15 is 1,000 views, 10,000 views, what we can then say is that €45 is 3 times bigger than €15, so 45 euro will be 3,000 views. Another way to do it would be to figure out what €1 is. To find out what €1 is, you divide by 15 and then multiply it by 45 to find out what 45 views is, and once again you get 30,000. Same thing. Work out how much in euro they'll be paid approximately for 80,000 views. Okay, well this time we're going to do it differently. We're going to do €15 is 10,000 views, and 80,000 views is 8 times bigger than 10,000 views. So we can find, just multiply by 8. So 15 multiplied by 8, and you get, what's it, €120 for that. Another way of doing it would be to divide 15 by 10,000 to find out how much one view is. One view only earns you a tiny amount of money. Then multiply that by 80,000 to find out how much 80,000 views will make it, which is €120. Okay, same thing. Work out how much in euro would be paid on average for one view of a video. We just did that a second ago. Let's do this. 15 divided by 10,000. Now in your calculator it doesn't come out too well. 15 divided by 10,000 is 3 over 2,000, which is 1.5 by 10 to the minus 3. But we're going to do this. What we might do is we might convert this to cent. So €15 is actually 1,500 cent. And what we can do is we can divide the 1,500 cent by 10,000, and it should work out a bit better. Which is 0.15 of a cent. One view equals 0.15 cent. Okay, that'll do you. Now it wants it in euro, so that's not good to me. So I'm going to have to divide 0.15 by 100. So when I divide it by 100, I get 2 extra zeros. So it should actually be 0.15 euro. Okay. So once it in euro, I don't know if cent includes for euro. So that's 9. The video costs them €70 to make. It does not cost them anything to post a video on YouTube. Write an expression in X for the profit in euro they will get from X views of the video. Profit. Our profit is costs, it's revenue minus costs. And your revenue is how much money you make. So it's 0.0, what did we say earlier? 0015, is that correct? 0.0015. Sorry, 0015. So for every view you get, 0.0015 multiplied by X, because that's how many views you have, take away your cost of €70, and that will be your profit. So if I was to enter this function in a calculator, okay, 0.0015 X, I can actually check my workings here, and then minus 70. And I'm going to go up in thousands, so I'm going to start at 0, end at 20,000, actually end at 100,000, go up in steps of, I don't know, 5,000. So if we just check something from earlier, remember that we get paid 80,000 views, we get paid €120. So for 80,000 views, it should be €120. Take away the €70 needed to produce the video. It should be 50. So I'm going to check 80,000 on my calculator to make sure my equation is correct. Okay. And lo and behold, it is €50 profit for 80,000. Okay. So this formula works. Okay. There are 7 people in the group. They divide the profit from the video evenly between the 7 of them. If they each get €200 profit, write an equation X to represent this information. So how many views did they need to make this happen? Well, put it this way, guys. It's 7 multiplied by 200, because if they each get €700 in profit, that's 1,400 in profit total. So the amount of profit has to equal 1,400. Okay, now if we look at my calculator here, you can see that the profit's going up here. All right, now stop at 100,000, but let's imagine something else. Let's start at 100,000 and go up to, I don't know, 300,000 views, and do in steps of I don't know, 10,000. Now let's have a look at this. 100,000 gets you 80 quid, but we want €1,400. So if we keep going down, we can see that we're nowhere near 1,400. So let's go for 500,000 views. And let's end at 1,000,000 views. Okay, and just have a quick look. Step of, I don't know, 50,000. Okay, so 550,000 gets you this much. Now we're trying to find out 1,400 here. Somewhere in between 950 and 1,000,000 views, we go from 1,355 up to 1,430. So it's going to be somewhere in the 950,000 to 1,000,000 mark. So check this out. We need to find out the X value. So bring 75 out the other side and we get 1,475. Next, we're going to divide the 1,475 by 0.0015. So 1,475 divided by 0.0015. I'm sorry. 1,475 divided by 0.0015. Roughly 983,334 views. We have to round up because 333 views won't be enough. So 988,334. Okay. That's, sorry, my fault. This is 70, not 75. That's why the number was so weird. It's actually 70, not 75. Sorry guys, my fault completely. So it's 147, so I have to go back to my calculator. Mode, table function, go for, what's it, 0.0015x, take away 70. Remember, start at about 950,000. n at a million, going steps of 10,000, I suppose. And you can find out that 950,000 earned you this much, and we can see that 980,000 earned you €1,400. So it's actually, it was a 70, not a 75. So if I divide 1,470 divided by 0.0015, we get 980,000. So x equals 980,000. Sorry, my bad. Oh, we already did that. Great. So the part one is just the equation, and part two here is working it out. So we're all good. Okay. So that's E part two done. Now, question 11. So we got to put down numbers on the number line. Now, key thing to remember about number lines is that when it's a shaded in line, see the way it's a shaded in line and not dots, a hollow dot means it's not included, and a full dot means included. So this is why there's a less than or equal sign that includes the -3, because it's allowed to be equal to -3, and this is why the 2 is not included, so that means there's only a less than sign. It's a line, so it's R. Now this is dots, which means it can be N or Z. However, it's not included is basically, it has negative numbers, so it has to be Z. You could do this two ways. You could say -4 is not included. That means you have to start off at 3 minus 2, and you could say x, and then you could say less than 2. That's one answer. You could change it to less than or equal to 1. That's another answer, because you're allowed to include the 1. Another answer could be you do -3 less than or equal to x less than or equal to 1. All those answers are good. Now this one here, we know it's n because it's 1, 2, and 3. Starts at 1, we include the 1, and it ends at 3. You could also say 0 less than x less than 4 if you wanted. There's many permutations you could use here in these answers. This one's not included, this one's also not included, so it's -2 less than x, because it has to go all the way up to 1.999, so -2, anything bigger than -2, but then again anything smaller than 4, because it can be 3.99 as well, and this is element R. Okay, now this is question 11. Okay, next part. Write the following, this is question 12, write the following as a fraction. So get common denominator. If all you did 2/3 take away 3/4, what you can simply do is the 3 looks over at this 4 and says I'll have a 4 top and bottom. The 4 looks back at the 3 and says I'll have a 3 top and bottom. And then basically get 2 times 4, which is 8/12. Take away 3 times 3, 9/12. 8/12, take away 9/12 is -1/12. We're going to do a similar method here. We're going 2 over n minus 3, and then we're going to have -5. That minus belongs to the 5, just to let you know, so we might just move the minus up towards the 5, and that's 2n plus 5. Now to look across at each other, the n minus 3 sees the 2n plus 5, so you do 2n plus 5 top and bottom, in the same way you did the 4 top and bottom. The m2n plus 5 looks across, sees the n minus 3, so you do n minus 3 top and bottom, like so. Now we're going to find out what to do here. Now you can't get rid of the denominators because it's not a solved question. In solved questions, when there's an equal sign and the denominator is the same on both sides of the equal sign, you can get rid of the denominators, but in this question you can't. You can't just simply get rid of the 12 in this question. That would make no sense, because -1/12 is not the same as -1. So therefore, we got to keep the denominator. 2 times 2n is 4n, 2 times 5 is 10, -5 times n is -5n, and -5 times -3 is +15. Okay, and what we get next is 4n. 4n take away 5n is -1n, and 10 plus 15 is 25. 25 minus 1n over n minus 3 into 2n plus 5. Okay. Show that this is positive for all values of x. Well, basically, for example, is if this is a negative number, so for example is if x was equal to 0, 4x minus 3 is negative. Okay, so that would mean that, okay, that would be negative. And a negative number squared equals a positive number. So a negative number squared equals a positive number. Okay, I think we're going to actually have to multiply this out. This is actually harder than I thought. Let's try multiply it out first, actually, because I forgot about the 24x over the other side, and that doesn't help things. So I'm going to multiply out this here. Multiply out 4x by 4x is 16x squared. 4x by 3 is minus 12x. Minus 3 by 4x is minus 12x. Minus 3 times 3 is 9 plus 24x. Now the x's cancel, so you're going to be left with 16x squared plus 9. And why is it always positive? 16 times a positive number plus 9 is always positive. X squared has to be positive. A squared number is always positive. For all x. So any number, whether it's negative or positive, if you put minus 1 in, minus 1 squared is plus 1. 16 times plus 1 is plus 16. So it doesn't matter if x is a negative or a positive number. When you square it, it's always going to be positive. That's why x squared is a positive number. Okay. So that's part 12. Now we're on to part 13. 12. Now we're doing 13. Okay. Below are 4 statements about 3 non-empty sets P, Q, and R in universal set U. Okay, so what we're going to do is we're going to set up a Venn diagram. Okay, we can just set up a simple Venn diagram with 2 of them at the moment. So 1, 2. Okay, now first thing we're going to do is we're going to put in some letters like A, B, C, D, and E. Now, in this case, the cardinal number of P union Q is 1, 2, 3, 4, 5. That'd be 5 in this case. And then cardinal number of P would be 3. And the cardinal number of Q would also be 3. So we can see that it's false here. Okay. So we're going to actually need this in the for our next answer. We'll put onto the we'll put onto a new page. You'll see why I'm doing that in a second. So it says in part B, I read through part B earlier, that you need to justify the answer to statement 1. So that's what we're going to do. So paste. So what we say here is hashtag P union Q equals 5. Hashtag P plus hashtag Q is equal to 3 plus 3, which equals 6. So currently they are not equal. Okay, but if I go back, and what I say this time is that neither one of them have any intersection. So as an example, if I was to put no intersection here, this time, once again, I'm going to need this for my next page. So once again, we're using this to justify statement 1. So you can see in this case that P union Q actually does equal hashtag P plus hashtag Q. So Okay, in case B, P union Q, hashtag P union Q equals 4, hashtag P equals 2, hashtag Q equals 2, hence P hashtag P union Q equals hashtag P plus hashtag Q. But in this case, hashtag in case 1, hashtag P union Q does not equal hashtag P plus hashtag Q. Sometimes they're equal, sometimes they're not equal. So that would mean sometimes true. Is P less Q the same as P intersection Q? I don't think that can ever be true, but let's find out. So let's do A, B, C. Everything in P that's not in Q is A, and P union Q is B. Well, that's not true. All right, let's try something else. What about P being empty? Let's just put P as empty and Q as empty. All right, so everything in P that's not in Q is P intersection Q. So everything in P that's not in Q is empty. P intersection Q is also empty. So it's the null set, not 0, but it's actually the null set. It's just empty. So what would oh crap. So the answer in the marking scheme is never true. Everything in P that's not in Q is the same as P intersection Q. Now here's a scenario where look, P there's just nothing in common. So everything in P that's in Q is empty, and then everything in, so it's hard to know if this set exists. So I'll actually show this example now. The answer in the marking scheme is never true, but here's an example where it is true, because everything in P that's not in Q is the null set, and everything in P that's not in Q is also the null set. Everything in P and Q is also the null set. So I don't know. Maybe that's not. Maybe using null sets isn't a valid explanation. So I'll have to figure out that a bit more later on. All right, next one. P intersection Q complement is the same as P complement union Q complement. So once again, just fill out all 3 sections first. I'll see what's going on first. P intersection Q. Everything that's outside P intersection Q. So that would be A and C for the first part. Nextly, everything that's outside of P is C. Union everything that's outside of Q, which is A. So in this case, the two of them equal each other, which is great. Might try a scenario where there's no intersection. Still works. So this is always true. So always true is this one here. Okay. Next one. This is the distributive function where you multiply it in P union Q. So this is always true. It's the distributive function. You can try it out if you want yourself, but there's no need. It's the distributive function where you're basically multiplying it in. Remember, it's like 2 multiplied by 4 plus 2. You can distribute the multiplication over the addition. So this is basically the same thing. You're multiplying in the union. Imagine the union is multiplication and the intersection is plus. So that's essentially, sorry, the union is multiplication and the intersection is plus. So essentially we're doing the same thing here. So I know that's always true. Okay. I think that's us, guys. Wait, there's probably another part somewhere. Ah, here we are. And I justified part B earlier. Okay, so that's already done. Use factors to simplify the following. 2 times minus 15 is minus 30. Two numbers that differ by 1 plus 1. So that's going to be 6 minus 5. So it's going to be 2n squared plus 6n minus 5n minus 15. Factorize that, I get 2n into n plus 3 minus 5 into n plus 3. I'm going to get a 2n minus 5 bracket n plus 3. Then on the bottom is the difference of two squares, which is going to be n plus 3 and n minus 3. And we can see that the n plus 3 is cancelled, and our answer is 2n minus 5 and n minus 3. Alright, so that's part A. Now part B. For all values of a, b, and x is an element of R, what they're basically saying is that x plus a and x plus b equals x squared a plus bx plus a multiplied by b. Using this factor or otherwise, answer the following two questions. Solve each of the following equations in x where a, b are constants and give your answer in terms of a or b. Okay, see this here, guys? See this blue box? Basically, this blue box equals this green box. And instead of writing down the blue box, I'm going to write down the green box, like so. Okay, and remember, if we had something like x plus 3 and x plus 4 equals 0, our answer would simply be x plus 3 equals 0, x equals minus 3, and then x plus 4 equals 0, and x equals minus 4. So what we're going to do here is we're just going to say that x plus a equals 0, and x plus b equals 0, and then transfer over to b and the a. So x equals minus a, and x equals minus b. Very unusual question, quite confusing actually. Now, then we go down one, and it says simplify this. Now, once again, this is the blue box. I'm just going to replace it with the green box. So we're dividing x plus a by x plus b all over x plus a. And once again, these are exactly the same, so they cancel, and the answer is just x plus b. Quite a tricky question at the end, guys, to be honest. Okay, so that's question 4.